Welcome back to Science Monthly for all your monthly science stories. In news this week, a team of researchers in MIT, Oregon, led by Shokrat Matopov, were able to successfully and safely delete a mutated gene, MYBPC3, which gave the embryo hypertrophic cardiomyopathy. And because of hypertrophic cardiomyopathy being a dominant trait, every embryo was going to have this trait. The researchers used the CRISPR gene editing. CRISPR gives the researchers a protein called Cas9, and this protein is used in bacteria cells. When that bacteria has a virus enter it, two pieces of RNA are released. The RNA binds with the Cas9, and the Cas9 finds this spot in the viral DNA. Once the spot is found, it binds with the DNA and cuts it off, which kills the virus. We use this protein and put the RNA into the protein that we want deleted, and we put it into the embryo. It will search through the DNA looking for this gene and cut it out. As the body tries to repair itself, which it usually does incorrectly, we insert the piece of DNA that we want in its place. While this is still far off from being used in everyday life, it shows that it may be possible to safely and accurately edit human genes. This is a field of research that's been around for a very long time, and our researchers were able to find that it's been around for at least 67 years. With the original outbreak of the H1N1 virus in the 1950s, the laboratory that the virus escaped from in 1977 is still unknown. Other than that, our researchers were not able to find any earlier research for gain-of-function. Throughout all of those years, most of the research has been on viruses and bacteria. Even with all this time, gain-of-function research is still very far from perfect, as any problems that arise can have huge consequences. Since we are making diseases stronger, if any are put into the wilderness, it can have some very large problems, like the bird flu that can be transmitted through ferrets, and it's also become airborne. If a stronger version of a virus is released, and it can affect humans, then there would be a public outrage. If it targets plants, then it could be an economic disaster, depending on how reliant the country is on its own food. It could go from self-sustaining to needing to buy from any country that's willing to sell, and that costs money, which the country may not be able to pay at the time. Not only that, but it can go into ethical issues, because it's still a disease, and we want to find a cure, and we want to know what it can do. So animals may need to be tested on, and if the cure doesn't work, then we could have just subjected it to a very slow and painful death, or quick and almost painless one, depending on the virus or if it's killed. However, this research is very important as it teaches us how viruses and bacteria work. And if we know how they work better, then we can find out better ways to fight them off, which can be good politically and it can be good economically, since we won't have to put as much resources or time into a cure. This could also be very good environmentally, since we may also be able to modify plants to be resistant to the diseases. Currently, the regulation of gain-of-function research is minimal at best. For most countries, currently the US, the government can't fund any gain-of-function research, but privately owned companies can fund them, allowing things like CRISPR to be used as research without being illegal. Other countries are also using CRISPR for gene editing, and other than some slight restrictions, it is allowed in almost every country, excluding Canada. This is something that I find to be really unnecessary. Canada banned all kinds of genetic experimentation if it's able to be passed down, and that is just going to keep Canada behind in this field of research, which could be very helpful, not only for people, but for animals and agriculture too. Scientists, however, have been fighting very hard for the ability to use gain-of-function research. They have tried loopholes as well, and it's all ended in failure. Sadly, that is all the time we have today. Catch us next month as we talk about birds, the next advancement in human warfare.